Welcome to Chemistry Made Simple. Today we are going to look at the continuation of our topic, redox reaction. Today we are going to look at the new subtopic, which is the concept on the identification of oxidizing agents and reducing agents. So that is the topic we are going to look at today. And then we are going to look at identification of oxidizing agents. Here we are going to look at some technicalities. Very simple as to how to identify oxidizing agents. Thank you as you enjoy this video. Now join me to the board as we look out the identification of oxidizing agents. Now the question that comes into mind is, what do you look for? Now, you look for I. The substance. So we look for the substance that accepts electron or electrons or hydrogen or donates oxygen in redox reaction. So that is what we're looking for. We're looking for the substance that accepts electrons, 1, or accepts hydrogen, 2, or donates oxygen in redox reaction. Now, in simple words, we are going to look at it in various terms as to how we have described it over there. So generally, what do we look for? Generally, we look for So generally, what do you look for? All substances that undergoes the processes of reduction. That is reduction reaction. So we're looking for substances that undergoes the process of what? Reduction or reduction reaction. Now, we are going to look at this concept of identification of oxidizing agents in terms of certain technicalities that we have introduced over here. So we are going to look at the first one, donate oxygen. So A, in terms of donation of oxygen, that is called removal of oxygen. You agree with me that under reduction reaction it is removal of oxygen, or you can say donation of oxygen. So we're looking for the substance that donates oxygen or we remove oxygen from. Now, a very simple example. We are going to look at copper 2 oxide reacting with hydrogen gas. Then it will produce copper 2 plus water molecules. So here we can technically see that copper 2 oxide donates oxygen to hydrogen gas to form water molecules. So therefore we can say that CuO undergoes reduction So CO undergoes reduction. And if CO undergoes reduction, then we can simply say CuO is reduced. So we can simply say that CuO is what reduced. CO undergoes reduction. Why? It donates oxygen to hydrogen gas to produce water molecules. Therefore, CO undergoes reduction process. This implies that CO is reduced. Therefore, we can technically say that CuO is an oxidizing agent. So technically we can say that CO is an oxidizing agent. Now that is how we are able to identify the oxidizing agent. So it means CO over there is the oxidizing agent. Now let's look at the second point. The second point, we are going to look for the substance that accepts hydrogen. The substance that accepts hydrogen. The substance that accepts hydrogen. So we are going to do that in terms of addition of hydrogen or acceptance of hydrogen. So addition of hydrogen or acceptance of hydrogen. Let's look at a very simple example. Now we have hydrogen sulfide plus chlorine will produce HCl plus that. Now let's look at it in terms of addition of hydrogen or acceptance of hydrogen. You realize that chlorine accepts hydrogen from the hydrogen sulfide. See, chlorine accepts hydrogen from the hydrogen sulfide to produce hydrochloric acid. So let's balance it. We have to balance the equation. Now hydrogen is 2, chlorine 2 is 2. So hydrogen, we put 2 there, it balances chlorine directly. So we have balanced the whole equation. Now we have seen that chlorine accepts hydrogen from the hydrogen sulfide to produce hydrochloric acid. So this indicates that reduction takes place. So Cl2 undergoes reduction. So technically we can say that Cl2 is reduced. Then therefore we can say Cl2 is an oxidizing agent. So Cl2 is an oxidizing agent. So we are seeing it there nicely. Now see, in terms of acceptance of electrons or in terms of electron transfer. So in terms of acceptance of electrons or electron transfer. So in terms of electron transfer, let's look at it, a very simple example. We have already distinguished that chlorine is an oxidizing agent. If it is an oxidizing agent, then let's use this process of acceptance of electrons to also verify whether it is true. Now, under the electron transfer, the acceptance of the electrons, because we know Cl2 is an oxidizing agent and therefore undergoes the process of reduction. A reduction in our previous lessons, I've already discussed with you that if you want to look at reduction in terms of electrons, we add electrons to the reactant side, which is the left hand side of the equation. Therefore, we are going to take chlorine, which is a diatomic molecule, and then it will produce Cl minus. here this indicates that chlorine needs 1 electron in order to complete its valence shell, so that it will attain an octet shell at its valence shell. So we have plus, so it means I'm going to add electron to this side. Now, because I've added electron to the left hand side of the equation, really explains that it is reduction process that is taking place over there in chlorine. So for me to balance, therefore we know Cl2 plus E produce Cl minus, and in balancing I'll have to put 2 over here because you have 2 molecules of chlorine, and then I'll put 2 over here so that the charges will be balanced and the number of electrons also will be balanced alongside. So we have that. Now this indicates that reduction has taken place in chlorine. Therefore, chlorine is an oxidizing agent. Since reduction has taken place in chlorine, then chlorine is an oxidizing agent. Now we are done with the identification of the oxidizing agent. We are going to identification. So we are moving to identification of reducing agents. Identification of reducing agents. Now that one, to a simple question comes, what do we look for? What do we look for? Now we are going to look at it. We look for I. That donates electrons. That donates electrons. That donates electrons, or hydrogen, or accepts oxygen in redox reaction. So the substance that donates electrons or hydrogen or accepts oxygen in redox reaction. So generally, what are we looking for? So like the other one, all substances that undergoes the processes of oxidation. So the processes of oxidation. That is oxidation reaction. That is oxidation reaction. So we are looking for a substance that donates electrons or hydrogen or accepts oxygen in redox reaction. Let's first think in terms of addition of. Remember, we are dealing with what we look for. So we said one, we'll be looking for the substance that donates electrons or hydrogen or accepts oxygen in a redox reaction. Two, all substances that undergoes the processes of oxidation. That is oxidation reaction. And then we said we want to look at it in terms of certain terminologies as used in the ideology of what we look for. So under the ideology of what we look for, we said we're looking for certain things specific. Now, in terms of addition of oxygen, said we pick the ultimate example that we have used previously, of which we have CuO plus H2 to produce Cu plus water. Now, what comes into mind? Here we have seen that in terms of addition of oxygen, copper 2 donates, and therefore hydrogen accepts. So you see hydrogen we have hydrogen. So addition of what? Oxygen. You see, so CuO donates and then hydrogen accepts. So you see accepts oxygen over there. Accepts oxygen. That is in terms of addition of what? Oxygen. So you can see that hydrogen accepts the oxygen. Therefore, within this process, we can say that H2 undergoes oxidation process. So we can technically say that H2 is oxidized. Hydrogen is what? Oxidized. Therefore, H2 is a reducing agent. Now, the B. In terms of donation of hydrogen or removal of hydrogen, we said the substance that donates ultimately is the substance that undergoes what? The oxidation process. So it donates hydrogen or removal of what? Hydrogen. That one, we pick the second example, which is H2S plus chlorine produce hydrochloric acid. What does it mean? Let's look at it. We remove hydrogen from this place and then added it to chlorine. We can also say that we added or we donated. So it means H2S donated hydrogen to chlorine to form hydrochloric acid, and the equation is balanced nicely. So what can we say about H2S? H2S undergoes oxidation process, as you can see it over here nicely. So H2S is oxidized. If H2S is oxidized, then it's a reducing agent. So technically, we are able to identify that it is a reducing agent. Now let's look at the third point, which is C, in terms of electrons or electron transfer. Now we looked at a very simple equation where we had Fe2, iron 2 ions, and then iron 3 ions, and then we also had chlorine and then produce chlorine ion. Now I said let's pick the equation that expresses oxidation, and the equation that expresses oxidation is the iron 2 ion. So the iron 2 ion loses one electron and then becomes iron 3 ion. So we balanced it with 2. Here we have a charge of 4, and then here we have 6, and then the 2 minus. we have the 2 minus over there, so it indicates that here the charge is 4, and in this case the charge is 4. Now oxidation takes place in iron 2 iron when it loses. So it loses 1 electron to become iron 3 iron, and you balance it in that manner. Therefore, Fe2 is a reducing agent. So that is how we determine reducing agent. Technically, today we have come to study the identification of oxidizing agents and then the identification of reducing agents. We have also looked at how to determine the individual substances that undergoes the various processes as to how to identify the oxidizing agent and then the reducing agents. Thank you for watching this video. See you in the next tutorial. See you in my next tutorial where you will enjoy the various parts and then problem solving, how to solve problems under the identification of oxidizing agents and the reducing agents. See you in my next tutorial. Bye bye.